All right, this is the last skill in the text, skill 16. That's not totally true, actually, but it's the last skill we're going to talk about. So what we're going to do is put all the trigonometry that we've been learning to use. And so our application here is about percent grade. This is essentially a way of measuring steepness, and as far as we're concerned, it shows up a lot when you're talking about steepness of a road. If you've ever been sort of driving on the highway or even not on the highway through, any place that has a little bit more of a mountainous kind of terrain, you'll sometimes see signs that say sort of, X percent grade, right? 6% grade. I saw one the other day that said 9% grade. And it's a measure of the steepness of the road. This is important for things like trucks that weigh a lot, and if a road is a certain steepness, right, going downhill, something that weighs a lot, like a truck, can actually get out of control, and that can be really bad. So it sort of helps people to know if there's a steeper part coming up, to sort of downshift and sort of keep a big truck under control. The way this is measured, so percent grade, you can see the formula here and a sort of little visual that goes with it. It's a comparison. You're sort of setting the vertical distance over the horizontal distance. If you've ever done slope in an algebra class, you can think of this as rise over run. It's the exact same kind of formula, right? It's this sort of vertical change over the horizontal change. So it's that just converted into a percentage, right? So it's this sort of rise over run times 100%, right? If you, in general, if you just sort of divide the two things together, you get some sort of decimal. On any kind of practical road, you could then see, okay, what would it take to get these two values to match? You'd have sort of a 45-degree angle if the sort of rise and the run were matching. That would give you essentially a 100% grade, which sort of, while in a picture might not sort of seem super steep, in fact is sort of pretty steep, would feel pretty steep to sort of go up or go down. You can also see in this picture, right, we have a theta. This is our just classic right triangle. So all of these things, the angle and sort of this, vertical and horizontal distance, these would be sort of the opposite and the adjacent sides. So there's sort of trig in the mix here. There's a whole lot of different ways we can sort of approach this. The simplest thing, just to sort of get started though, is just do some calculations. So for example, if we're trying to sort of just find the percent grade, given some of this information, right? So a 250 rise and a 5,000 foot run. Keep in mind here, right, the sort of run value, this is a sort of directly horizontal value. If you're thinking about how to measure this would actually be sort of trying to take a measurement like into the hill, directly into a hill, versus like you can see where the car is in this picture, right? The car itself is actually sort of on the slant, is on what would be the hypotenuse of this triangle. So what you would sort of get off of your, odometer in terms of actual distance traveled is going to be a little different than this sort of run distance. We'll kind of come back to that at the end of the chapter when we look at some other examples. In any event, so if we have these two values, it's just a matter of setting them up, right, and then doing a quick division and a quick multiply. So if I know this is a 250-foot rise over a 5,000 foot sort of run, so over, almost a mile. If I just set this up, 250 over 5,000 times by 100, that would get me sort of 0.05, right? Times 100 is a 5%. And so our percent grade here would be 5%. So if we have these values, this is a pretty quick calculation to find. If we take the same triangle right into our second example here in this section, if I take the same triangle, 250 and 5,000, I can do a different setup, and I can actually find what here would be the angle of incline, the angle of elevation. So the theta here in the corner, another way of sort of talking about the steepness here would be to sort of talk about this angle. So how am I going to relate these things together? Well, if I think of this in terms of the opposite and the adjacent and the hypotenuse, I know this rise value would be the opposite. I know my run value would be the adjacent. So I can sort of set up a situation. Which of my trig functions uses the opposite and the adjacent? Well, that would be the tangent function. Little cat foot in the mix. Hey, Max. Max loves the tangent. And so what that means is if I'm trying to do something like find the angle, so the tangent of the angle would be the opposite over the adjacent. Thanks, Max, for pointing it out. Yep. So that means the tangent inverse, right? If I could do the inverse of the opposite of the adjacent, that would set me up to actually find this particular angle. So I can do that, right? 250 over 5,000 would be my opposite over the adjacent. We know kind of already, right, from the previous problem, that would be a 0.05 in the calculator. So if I do tangent inverse of that value, right, calculate it out, that's going to get me an angle of elevation of 2.86 degrees. Now, you know, that's not really to scale, right? That would be a very tiny angle. And so your triangle would almost look flat at that rate. Just something to consider. All these pictures, right? In theory, we're trying to draw them as best we can, but they're not necessarily always to scale. A couple quick problems just from the book. You guys are doing, I believe it's the evens for the homework here, so I've picked some of the odds. If we look at number 3, talking about finding the percent grade and the angle of incline, so that's both of the things that we just did in this last example. If I sort of draw a sketch, right? One thing to do here, just always watch that your sort of units are in sync. So just a quick little conversion here. I've got 1,200 feet for my rise. I have 3 miles for the run, the horizontal. So times a quick 5,280, right? 5,280 feet per mile. So that's going to be 15,840 feet. So my percent grade is just setting those two over top, right? 1,200 over the 15,840 times 100%. That's going to be 0.0758 times 100. So that's going to be 7.58%. So my percent grade there, that's a little steeper than the last one that we did. If I want to do the angle, well, then I'm going to say the tangent of the angle, right, would be my opposite over my adjacent. So that's the same setup, 1,200 over 15,840. Just like we have, that's going to be 0.0758. So then if I do tangent inverse of that value, that decimal value, it's going to spit back whatever this angle of incline is, this sort of angle of elevation. So it looks like that's going to be, for us, 4.3 degrees. That makes sense. This is over a little bit. These are sort of bigger values than the one we did in our sort of first example. And it looks like it's also going to be somewhat steeper, a bigger angle. And let's pause there for now. We'll catch the next one in the next video.